All right, welcome once again. We have Amobi Publishers, number 24. This is paper 1, remember. A particle moves with a speed v equals -5 plus 3t squared meters per second through a point O at s is equals to 10 meters when t is equals to 0 seconds. Now determine A, an expression for its displacement s after t seconds. Now, if we have been given v, the expression for s will be the integral function of v. In other words, you integrate you integrate v with respect to t. So we have s is integral sine v dt, which is equals to -5t plus 3 over 3t raised to power 3 plus c. And we must add that constant there. All right, every other time you integrate, you must add a c, which is a constant. Now on simplification, this one becomes -5t plus t raised to power 3 plus c. If you rewrite this one, you can also write t power 3 minus 5t plus c. All right. Now, if you want to get c, you insert the values t is equals to 0, s is equals to 10 into the equation, or the integral equation, -5t plus t power 3 plus c, and you equate that one to s. So s equals to 10 when t is equals to 0. We have 10 equals to 0, that is -5 into 0 plus t into 0 cubed plus c, right? So 10 equals to 0 plus 0 plus c, and this one gives us a value of c equals to 10. So substituting the value of c into the expression -5t plus t power 3 plus c, we have s is equal to t power 3 minus 5t plus 10. It has been rewritten in an orderly way so that we have the power of 3 coming first, and then followed by the power of t raised to power 1 and the power of t raised to power 0. Now b, the requirement for b, it's displacement after 2 seconds. So displacement s will be now 2 substituted into t raised to power 3 minus 5 into t plus 10. And this is what we have here. So s is 2 power 3 minus 5 into 2 plus 10. And when you evaluate that, we have s is equals to 8 meters. I hope you are following up to that point. Requirement for part C, this is an expression for its acceleration after, that is acceleration A, after t seconds. So the acceleration is now the derived function of v. So remember what we had across here. So if we want to get A, we get dv dt, and this one disappears, so we get 60. And this is what we have down here. So the acceleration dv dt is given by 60. Right, that is simple. Then we go to the next requirement. The next requirement is up here. It's acceleration after 10 seconds. So what do? We just substitute the value of 10 seconds into t, which gives us 6 into 10, which gives us 60 meters per second, or if you like, 60 meters per second squared. Requirement E, we are supposed to get time t when its speed v is equals to 0 to 3 decimal places. Now, if we want to get the t when speed is v is equals to 0, we equate the expression for v to 0. Remember the expression for v we had? So that 3t squared minus 5 equals to 0. And as you can see, this is a quadratic equation. So when we get the value of t here, we must get two values. And the reason here is simple, that a square root must have positive or negative. So 3t squared gives us 5, meaning t squared gives us 5 over 3. And therefore, t is plus or minus root 5 over 3. And here, if you evaluate that with your calculator, because we are not limited, then the square root becomes plus or minus 1.290994449 and so on. So if you round it off to 3 decimal places, we have plus or minus 1.291. Now, we are saying here, consider the positive value since there is no negative value of time at this stage. So it is important to state that we only consider the positive value because there is no negative time concept at this stage. So t is equals to 1.291 seconds when v is equals to 0, when the value of v is equals to 0 meters per second. Thank you very much for following. If you loved the video, like it, and kindly subscribe so that next time we have a video like this, you will get notifications and updates. Bye bye.